My name is Karara Muhoro, and I am a professor of chemistry. Today, I have a project called The Mechanism of the Dual Nature of the Coronavirus. That means the coronavirus has two properties. One, the coronavirus behaves like a particle, solid, vibrating in place. Liquids, particles move around over each other. Gases, on the other hand, move very fast. They move very fast. That's gases. Solid, liquid, gases. Particle nature of the coronavirus. Number two, the coronavirus behaves like a catalyst. A catalyst speeds up the rate of chemical reactions. In the human body, the catalyst is known as carbonic anhydrase. Carbonic anhydrase, an enzyme, a biological catalyst that speeds up the rate of chemical reactions. So these two properties are meshed together, or they are combined in such a way that they infect millions of people around the world and kill hundreds and hundreds of thousands of people around the world. The dual nature of the coronavirus. So the mechanism of the dual nature of the coronavirus is to inform the scientific community to unveil how the coronavirus uses these two properties to trigger the world pandemic. So the mechanism of the dual nature of the coronavirus is about the interaction between carbonic anhydrase and hemoglobin. Hemoglobin is the molecule that binds oxygen and transports to the tissues for cell metabolism. Carbonic anhydrase has a zinc ion at the active site. Zinc facilitates the abstraction of a proton from a water molecule that is bound to the active site. This produces a hydroxide ion. Hydroxide is rich in electrons. The hydroxide increases the acidity of the lungs, the acidity of the bloodstream. When this happens, hemoglobin binds oxygen and transports to the tissues. This graph percent oxygen saturation versus partial pressure represents that binding of oxygen to hemoglobin. The first molecule binds, we are looking at the green curve, and then there's a conformational change that allows more oxygen to be bound to hemoglobin. Oxygen is then transported to the tissues for cell metabolism. In the tissues, carbon dioxide is produced, but carbon dioxide is not soluble in water and must be converted to something that is soluble in water, bicarbonate. It happens like this. Carbon dioxide binds to the active site, the zinc ion, and the hydroxide can attack or react with carbon dioxide to generate bicarbonate. Remember, bicarbonate is soluble in water. This picks a proton from the medium and produces carbonic acid. The carbonic acid decreases the acidity of the lungs, the acidity of the bloodstream. Then carbon dioxide is expelled from the lungs, from the body. And the process begins again, regulation of acidity by carbonic anhydrase. A water molecule then binds to the active site, the zinc ion, and this mechanism continues again. This is a cyclic process, perfect under normal conditions. However, in the presence of the coronavirus, which acts like a catalyst, this perfect mechanism is reversed. It malfunctions. When this happens, there's an increase in concentration of carbon dioxide, which increases the concentration of carbonic acid. So there's an exponential increase in carbon dioxide, which increases the concentration of carbonic acid. This change in chemistry of the lungs, the chemistry of the alveoli of the lungs, is the cause for the world pandemic. Therefore, the mechanism of the dual nature of the coronavirus shows how the coronavirus changes the chemistry of the lungs, infecting the lungs so they no longer function under normal conditions. The lungs are inflamed because of the change in the chemistry of the lungs, the change in chemistry of the carbonic anhydrase active site. This change in chemistry of the lungs is the cause for the world pandemic. The world pandemic, the dual nature of the coronavirus. Thank you very much. I'll be back.